Hi there, welcome back to my channel. In this video, I'm going to talk about the properties of determinants of 3x3 matrices. In my previous video, we have learned how to find the determinants of 3x3 matrices. Since this is the second part of the video, if you are new here, then I suggest you watch the first part of the video before continue this video. You can click on the link on the top right corner, or you can also find the link in the description. If this is your first time here, and if you want to upgrade your math skill and boost your grade, then make sure you subscribe my channel by hitting the subscribe button below so that you won't miss anything. If you find that this video is useful, please share to your friends, to your students, or to anyone who need this. One more thing. Some of you might encounter difficulties when studying maths and need someone to guide and help you. So here I have created a Facebook group called Teacher Eileen Math Group. You are welcome to join the group, and you can post any question about maths in the group. I will try my best to help you. Here is the link of the group. You can also search the group in Facebook. I hope you can join us. In this video, I'm going to talk about the properties of determinants of 3x3 matrices. Now, there are a few properties of determinants that we are going to learn. So now we will look into it one by one. Now, for the first one, if any two rows or any two columns of a determinant are interchange, then the sign of determinant changes. This means that now, for example, here I have the determinant here. If I exchange the first row with the second row, or any two rows or any two columns, then the value of the determinant after interchange will change from positive to negative, or from negative to positive. Now we can verify this. So this is the determinant before changes. So now I'm going to find the value of this determinant by using the method that we have learned in the first video. If you are new here, so I suggest you click on the link in the description, or the link at the top right corner here, to watch the first video so that you understand how to find the determinant of 3x3 matrices. Then you come back to this video. So by using the method that we have learned, that is, we multiply the first value, first row, -4, with 2x2 determinant 1, -2, 5, -1, minus the second value, multiply with the 2x2 determinant 3, -2, 2, -1, plus the third number, multiply with 2x2 determinant 3, 1, 2, 5. Then we try to calculate the 2x2 determinant by using AD minus BC. Then we will get here. Then when we press calculator, we find that the value is equal to 19. After changes, so here I change the first row to second row to first row. Now I'm going to find the value of the determinant by using the same method. Then when I simplify, I find that the answer is negative 19. So we can see here, before changes, the determinant is positive 19. After changes, the determinant is negative 19. Now, property number 2. If both rows and columns are interchanged, then the value of the determinant remains unchanged. In property 1, the interchange only involves any two rows or any two columns. But for property 2, the interchange involves all the rows or all the columns. Now we look at this one. Now here we can see that the first row becomes first column, second row becomes second column, and third row becomes third column. So in this case, then the value of the determinant remains unchanged, means the determinant is the same. Property number 3. If any two rows or columns of a determinant are identical, then the value of the determinant is 0. So now let's look at this example. Here we can see that all the elements in row 2 and all the elements in row 3 are identical. Or here, all the elements in column 1 and column 2 are identical. So the value of the determinant is equal to 0. And we know that if the determinant is equal to 0, so we can make conclusion that the inverse of the matrix does not exist. Now for property number 4. If every element in a row or column is 0, then the value of the determinant is also equal to 0. So let's look at this example here. The elements in first row, all elements are equal to 0, or this example, all the elements in the second column are 0. So the value of the determinant is equal to 0. So therefore, we can make conclusion that the inverse of this matrix does not exist. Property number 5. If there is any common multiple or common factor in any row or any column, then we can factorize the common multiple or common factor. So let's look at this example. Now here we notice that all the elements in the first row are the multiple of 2. So means we can factorize 2 out from the first row here. Now the elements in the first row becomes negative 2, negative 1, and 2. Then after that, we notice also all the elements in second row also the multiple of 2. So once again, we can factorize the 2 out from row 2. So now row 2 becomes 3, 1, and negative 2. But after that, we also notice that all the elements in column 3 are the multiple of 2. So means once again, we can factorize the 2 out from the column 3. So now column 3 becomes 1, negative 1, and negative 3. So after finish, now we combine all the multiples outside here becomes 8. So now this property is a little bit different from matrix. For matrix, when all the elements inside the matrix are multiple of 2, then only we can do the factorization. We factorize the 2 out only once, not 3 times. So, and also if one of the element is not multiple 2, so we cannot do the factorization. Property number 6. The value of the determinant remain the same if we plus or minus one row or column to the other row or column. Now let's look at this example. Here I change the value of row 2 by subtracting the value of row 3, and I also can change the value of column 1 by adding the value of column 2. So now we go to property number 7. The value of the determinant remain the same if we add or subtract a multiple of one row or column to the other row or column. Now let's look at this example. Before I add the value of row 3, I multiply row 3 with 3, then only I add into the row 2. This one we can done also for column. Before I minus column 1 with the value of column 2, I multiply the value of column 2, then only minus the product to column 1. After we have learned about the properties of the determinants, now we are going to apply these properties of determinants in solving problems. Now let's look at this question. Show that the determinant is equal to A minus B multiply B minus C multiply C minus A. Now to do this, here I'm going to use 2 techniques. One is I'm going to change any row or any column to 1, 0, 0 or 0, 1, 0 or 0, 0, 1. That is, I can change any row or any column such that 2 of the elements become 0. Now another technique is I'm going to factorize the common factor from any row or any column. Now let's start. When we look at the determinant here, I can see that there is no common factor from any row or any column. So means this technique is not applicable, but I find that I can change the first column into 1, 0, 0, where I can change the first number in row 2 and first number in row 3 into 0. So first I'm going to change the first number in second row in 0. So to do this, now I'm going to multiply row 1, then add into row 2. So negative 1 plus 1 is 0. Negative A plus B is B minus A. Negative A squared plus B squared is B squared minus A. Then to change the first number in the third row into 0, now I'm going to multiply the first row with negative, then add into row 3. So negative 1 plus 1 is 0. Negative A plus C is C minus A. Negative A power 2 plus C power 2 is C power 2 minus A. After finish, I find that the second technique is applicable, where I can factorize B minus A. But before this, I need to factorize b squared minus a squared becomes b minus a multiply b plus a. And for the third row, I can see that there is one common factor, that is c minus a. But before this, I need to factorize c squared minus a squared into c minus a multiply c plus a. So after that, I can see that I can factorize b minus a from second row and c minus a from third row. So now when I factorize b minus a and c minus a, so second row becomes 1 b plus a and 1 c plus a. After this, I must double confirm that the factorization must be completely done. That is, there is no more common factor from any row or any column. So now I'm going to find the value of this determinant by using the method that we have learned in first video, where based on this rule. So now to find the determinant, here I'm going to use the first column where I change the element into 1 0 0. So by using the first column, the first number is plus 1 multiply 2 by 2 determinant 1 b plus a 1 c plus a. Then multiply the second number is 0 and plus third number is 0. Because second number and third numbers are 0, so we know that 0 multiply anything is equal to 0. So now I'm going to find the value of this 2 by 2 determinant by using AB minus BC. So now I get this one. So now after simplify, I'll get B minus A, C minus A, C minus B. But when we look at the question, the answer should be A minus B, B minus C, C minus A. So now, in order to change B minus A into A minus B, now I'm going to factorize the negative out. Then I'll get A minus B. Then same as here, I'm going to change C minus B becomes B minus C. That is, I'm going to factorize the negative out. Then I'll get B minus C. Then this negative and this negative will becomes positive. Then finally, I rearrange the position. Then I'll get A minus B, B minus C, C minus A. Now let's try this question. Show that this determinant is equal to ABC multiply A minus C multiply B minus A multiply B minus C. So same thing. To do this, I'm going to use these two techniques. One is change any row or column into 1 0 0 or 0 1 0 or 0 0 1. Another one is factorize the common factor from any row or any column. Now let's start. Now when we look at the determinant, first I can see that there are the common factor in first column, second column, and third column. That is A from first column, B from second column, C from third column. So first I factorize the common factor, that is A, B, and C. So after factorize, I will get this determinant. So now after factorize, I find that I can change the first row into 1 0 0. So to do this, now for the first number is in second column. In order to change to 0, now I multiply the first column with negative and add into second column. So negative 1 plus 1 is 0. Negative a plus b is b minus a. Negative a squared plus b squared is b squared minus a squared. Then to change the first number in third column into 0, now I multiply first column with negative, then add to third column. So negative 1 plus 1 is 0. Negative a plus c is c minus a. Negative a squared plus c squared is c squared minus a squared. Now after this, I find that I can again apply the second technique, where I can see that in second column I can factorize b minus a, and third column I can factorize c minus a. But before this, I need to factorize the b squared minus a into b minus a multiply b plus a, and c squared minus a squared into c minus a multiply c plus a. So after this, now I can factorize b minus a from second column, c minus a from third column. So after factorize, I'll get this. Now after this, I need to double confirm that there is no common factor from any rows or any column. That now I'm going to find the value of this determinant by using the method of finding the determinant. That is, I'm going to use the first row where I change to 1, 0, 0. So the first number is plus 1. Then 2 by 2 determinant 1, 1, b plus a, c plus a, minus the second number 0, plus the third number 0. Since 0 multiply with anything, the answer is 0. So now I'm going to find the value of this 2 by 2 determinant by using AD minus BC. Then I'll get this one. Then after that, I simplify this. Then I get this one. But when we look at the answer in given, the answer should be A minus C, B minus A, B minus C. So now, in order to change C minus A into A minus C, so I factorize the negative out. And also, in order to change C minus B becomes B minus C, now I factorize the negative. Now negative, negative becomes positive. Then I'll get the answer here. Now I rearrange the position. Now I get a final answer. So that's all for now. Do you understand what you learned today? Let me know in the comments below. If you find that this video is useful, hit the like button. Don't forget to subscribe to my channel. Thank you so much for watching. I hope you keep on learning and keep on watching my videos, and I hope to see you soon. Bye!